Have you ever wished you could control how fast light travels? I mean, light speed is supposed to be the ultimate speed limit, right? But what if I told you scientists have just figured out how to make light travel at different speeds, depending on which way it's going? Yeah, you heard that right. Even Einstein would do a double take. So here's the scoop. A team from the University of Manitoba and Lanzhou University has done something wild. They built a device that lets microwave pulses, think light, but in the microwave part of the spectrum, move slower or faster, depending on the direction they travel. And here's the kicker. The amplitude, or the strength of the signal, stays pretty much the same no matter which way it goes. It's just the speed that changes. Let's break down how they pulled this off, because it's actually pretty clever. The device is called a cavity magnonics system. It's like a tiny playground for two types of particles. Photons, which are the basic units of light, and magnons, which are little packets of electron spin waves inside a magnet. The photons bounce around inside a dielectric resonator, while the magnons live in a small sphere of something called yttrium iron garnet, a magnetic material. Now, here's where the magic happens. The material has what's called chirality, which means the electron spins all twirl in the same direction, set by an external magnetic field. Add in a carefully designed microstrip, basically a tiny wire that introduces some energy loss. And suddenly, you get what physicists call non-reciprocity. In plain English, light going one way gets delayed. Light going the other way gets sped up. This is a big deal because until now, scientists could only use non-reciprocal devices to control amplitude, like isolators and circulators that let signals through in one direction but not the other. But with this new trick, we can let light go both ways, just at different speeds. It's like a two-way street, but traffic in one lane moves in slow motion, while the other lane is the Autobahn. Why does this matter? Well, imagine what you could do if you could precisely control when a signal arrives, in high-speed telecom networks, in quantum computing, or even in brain-inspired neuromorphic chips. This could open up new ways to route information, avoid signal collisions, or process data way faster and more efficiently. The effect is still pretty modest for now, think milliseconds, not minutes, but the team is already working on ways to make it more powerful and practical. That means we're just at the beginning of a whole new era in controlling light. So next time you flip on a light switch, remember, somewhere in a lab, scientists are already bending the speed of light to their will. And who knows, maybe someday that technology will be powering your phone, your computer, or even the next generation of the internet. If you're as blown away by this as I am, hit that like button, because the future of light just got a whole lot brighter.